All right. So the whole idea here is not for us to talk at you guys very much. We had a presentation a while back about what's coming with the NServiceBus next major version, which is version 6. In the blog post that we linked from this invitation that you can see over here on our website, the NServiceBus 6 public beta. You'll have hopefully already seen all of the information about async await and the API in Azure. So if you haven't taken a look at that, please do. The link again is in the notes. The main idea here is for us to just kind of re-summarize things that you might not have known, say a few words about them, and to really open it up for more interactive Q&A session for you guys to tell us what are the things that you're worried about, things that you're hopeful for, things that you'd like to see coming sooner rather than later. So at the main level, I'd just like to summarize what we've been doing with version 6 into 3 main areas: performance, cleaner API, and testing. So async await falls very much under the category of performance. It's made quite a bit easier. Oh, I see somebody phoning in. Please mute yourself so that we don't have too much of an echo. So the main thing that async await has given us is really huge performance boosts around Azure and RabbitMQ specifically. MSMQ has also gotten better, but the huge difference was around Azure. We've done pretty much a top-to-bottom rewrite of a lot of the Azure functionality as a part of version 6. And getting it to support async await, and that's ended up having massive performance gains. And on the flip side, it also means that we're also quite a bit more efficient around resource utilization, so there can be some cost savings in there as well. So also, if you're using Sagas on top of Azure Storage Persistence, you'll see that there's a big performance boost over there as well. And the main thing that I can say is probably one of our more meaningful features that's coming around Azure in version 6 is the topic of high availability by supporting multiple namespaces. So that's been something that really wasn't asked for so much as we saw the opportunity to support it and to provide the next level of high availability, because every time there's an outage in any type of cloud environment, people immediately start thinking about, okay, how can I prepare myself for the next outage? How can I make a system that's more robust in the face of these type of outages? And what we've done in terms of the namespace failover model has been fairly significant. So if you'd like to hear more about that, please do ask questions. I think we've got Yves on the call with us, and he'll be happy to go into details in that area. RabbitMQ, also the async await there, has made a huge difference in terms of the performance profile. So for those of you that are using RabbitMQ, I think that you're going to really be happy to see what you're able to get out of the RabbitMQ transport. And I think we've got Brandon with us here who's been spearheading a lot of that work. So if you want to get into that, Brandon will be happy to get into the details. Around MSMQ, one of the interesting things that we found is that async did not have a huge difference there. Not on the same order of magnitude as Azure and RabbitMQ, is still a nice performance boost. The main thing about performance around MSMQ that we've done in version 6 is the concept of, in essence, getting rid of the distributor. So the distributor, for those of you who are using it, is this central point where all of your messages flow through and then it gets fanned out from as a kind of load balancer. We've created a kind of distributed load balancer with version 6 on top of MSMQ that allows for a much more peer-to-peer mesh in terms of message delivery. And that has really taken the scalability profile of MSMQ from kind of tapering off as the load increases to being quite a bit more linear across many more machines. And the big thing is that you don't really have to worry so much about clustering and the high availability of the distributor. So it should greatly simplify your deployment environment when using MSMQ. Onto the API, I want to say a few words about what we've done over there. Along the way of making everything async await friendly, we've had to revisit a lot of the user-facing APIs, including message handlers and Sagas, and making those more async friendly by having them return tasks. Along the way, what we've done in making that work is instead of you needing to inject a bus object into your handlers in order to be able to reply or publish messages, we have this thing called a handler context object, which will allow you to use all of the most commonly needed capabilities from the bus directly from your handlers without needing to do any dependency injection. This should hopefully also simplify the way that you end up setting up your own dependency injection, because our message handlers and what the NServiceBus pipeline needs is now not really going to be intervening in how all of your DI works. So that should be quite a bit easier for you if you needed to do some sort of special stuff around your containers. Sagas, we've tried to make them quite a bit more robust at the API level, making sure that all of the configure mapping statements will always be there and work correctly. So hopefully, again, not for those of you that are on this call, but the teams that you're leading should be able to write much more robust Sagas and handlers than they have in the past, and make a whole lot fewer mistakes. On the topic of routing, we've also simplified things a bit, specifically around how you go about scaling out. So we mentioned before that element of removing the distributor. We've taken a significant step in terms of dividing routing into two parts. First and foremost is logical routing. So which message types are going to be going to which logical endpoints. And then the physical part of that, which is which logical endpoint is deployed on which physical machines. And to have a separate API for you to be able to specify each one of those things. That also comes back together to that element of a no distributor scale out story. We've done quite a bit of work in that area to provide you with a very consistent model that is going to look very similar, again, whether you're in the cloud or on-premise, RabbitMQ, Azure Service Bus, etc., while still giving you the ability to hook into the specifics of those environments and to do things that might require some extensibility. The last bit for me, before I turn it over to all of you to ask questions, is talking about testing. The main reason why version 6 has been such a long time in coming is that because we've done such a significant change to a lot of the low-level implementations of NServiceBus, so all of the threading stuff, all of the transaction management, in rewriting that to make that work with async, we really wanted to make sure that it's bulletproof. And we've done a whole lot of testing, and we've written a whole lot more automated tests to verify that we haven't broken anything, because we know that that's really the number one feature that you look for in NServiceBus, is that it doesn't break, that it does what it's supposed to do, and there are no surprises in there. And given the size of the change that we made here, we really wanted to be double, triple sure, and we've been testing a whole lot around it. We've been going through a beta process. Maybe some of you have been in that beta process with us. Hopefully you've seen just how robust it is. In terms of the other testing that we've been doing, we've been making sure that you can run V5 alongside V6 side by side at a wire level, and that's just going to work for you. That you can have Sagas that started in V5 and that you're going to upgrade them to V6, and that at the data level, all of that's going to work for you just fine. We've invested a lot in performance testing. So when we say that it's faster, we've tested it across a very large cross-section of different machine sizes, and not only in terms of sizes, CPUs, disk, I/O, that type of stuff, and verifying how that behaves across the different transports. So really, testing has come a long way, and it's one of the reasons why I can say that we're very confident that when the release candidate is going to come out, that you can go live with it, and that it will work, and that you're not going to be losing data or any bad things going to happen. So we've released one beta. Since then, we've uncovered one critical bug that we're in the process of fixing. Coincidentally, it has nothing to do with async await. It's something else entirely around our SQL transport, and we're in the process of fixing that. And as we get that fixed and other parts of the detailed API nailed down, we'll be putting out a second beta. And then you should expect to see a release candidate, as as long as no other huge bugs are found in the weeks that come after that. So that's it for me at the high level of telling you what's been going on. If you haven't been tracking all of the things that we've been blogging about in V6, etc. So I see that the chat's been fairly lively so far. So let's take them one at a time. The first one is, we'd love to hear about the support for secondary Azure Service Bus namespaces. So Yves, you want to say a few words on the topic?
Yeah, I'll cover those. Actually, the first three are the same question. One thing that we already had in the past was support for sending across namespaces, meaning that we were already capable of sending from one endpoint, which is hosted on namespace 1, to a second endpoint, which is hosted on namespace 2. But both endpoints had to be hosted on different namespaces in order to do that. What we introduced now in V6 is actually a concept that we call a topology. A topology is a certain layout of Azure Service Bus entities in the large sense that is shared between different endpoints in the system. So these entities, they can be queues, they can be topics, and they can be from different namespaces. So that basically means that the multiple endpoints can communicate with each other across multiple entities from multiple different namespaces. And the way that you set this up is configurable. So you can set this up for high availability. So you can say, well, these entities are my primaries, and these entities are my secondaries. If the primaries are not available for sending, then we fall back to the secondaries. That's one option to do it. Another option is to use this to overcome service limits. So if you have a scale out problem, you have too many messages a second for a specific namespace, then you can also configure it to use multiple namespaces together, right, in an active mode, so that you can overcome these limits. So you will have a lot more flexibility by combining entities and resources from multiple namespaces for your communication between your endpoints. And this is a very powerful thing, both for high availability, but as well for your scalability. You will never have to hit any kind of service bus limit anymore.
All right, great. Thanks, Yves. I think we have a follow-on topic that maybe you can say some words about, from Roy, asking about positioning in Service Bus in the new Azure ecosystem with service fabric, actors, stateful, stateless services. What are we focusing on in that ecosystem?
Yes.
So, keeping in mind that everything that we talk about in that area is more future oriented. There's not really much of that going into V6. and that everything that we say about sort of the longer term future should be taken with a grain of salt or two. The one thing that I'll say at a high level before turning this over to Eve is that actors are going to be a meaningful focus for us going forwards. We haven't talked very publicly about this yet because we're not quite at that point where we want to make a lot of noise, and we do realize that the actor community tends to be fairly vocal. Following NSPCon last year, where we had the opportunity to sit down with the Aka.net guys and to really go through a lot of the things that they're doing and compare and contrast that to what we're doing in NServiceBus, one of the things that struck me is that NServiceBus Sagas do a great deal of what actors do. And in many ways, they do it better in a more safe by default manner. Now, we're not yet at that point where I'd be willing to go on a public stage and say, NServiceBus Sagas are better actors, but we're getting there. And we're actually fairly close to that statement. What that means with regards to actors specifically in an Azure environment is slightly different, because the Azure environment level of protection and functionality around their actors is somewhat different than what you'd expect in an on-premise type of environment. So with that, again, saying everything future-oriented is with a grain of salt. Expect a lot more from us when it comes to actors longer term. E, would you like to say some more specifics about the Azure parts of Service Fabric, stateful, stateless services, etc.?
Yes, so we've done some experimentation with NServiceBus and Service Fabric so far. We don't have an official release of any kind, but we've done some proof of concepts with it. And the way we see the relationship is indeed at the same level as actors. So one of the big advantages of Service Fabric is that you have a durable, persistent story as a platform as a service model, which is something that we missed in Azure in the past. Like cloud services, you cannot really rely on the disk. So you cannot rely on the data being local. So you always have to use a remote service like storage. This is something that is very powerful, but it also has one very big shortcoming, and that is that the communication between the different services in Service Fabric is not durable at all. So it's just point-to-point communication with a little bit of retry flavor over it, but there is absolutely no guarantee that a message call will arrive on the other end. And that's where NServiceBus can shine to bring more durability to Service Fabric communication by leveraging the Azure Service Bus or Azure Storage Queues and similar services. And at the same time, we can also benefit from the Azure Service Fabric persistence model, in the sense that we can now have local state for things like Sagas or things like the Outbox. And combining that, having the local state, I think is a very powerful thing to actually have in an Azure environment. It's something that we couldn't do in the past. We could never rely on those disks. So we see it at the same level as the actors, as a programming framework. And we think we can bring something to Service Fabric programming model and the ecosystem, and we can also ourselves benefit from it. Right. All
right, absolutely. Thanks, Eve. We have a question from, I think it's Bastian, about RabbitMQ, about a specific type of bug. Brandon, are you familiar with that one? Can you say maybe a few words on it?
I would actually need a little bit more information. If it's what I think he's talking about, then yes, I believe that will be fixed because of the architecture changes in the MessagePop. One of the common places I've seen where you can get an end-of-stream exception is in the current queuing consumer stuff, and there are times when that can actually throw an exception if you try to queue for a message on the queuing consumer when there isn't a message. If that's the source of the error, then that should likely be gone because we're no longer using it. MessagePop's been completely redesigned. If there's another specific scenario related to that, I could certainly follow up on that if need be. But as far as I know, the one area that I'm aware of in Rabbit where that would potentially happen should no longer happen with the V6 version of the transport.
Okay, awesome. Yeah, that the scenario you're describing is what we're facing. So, awesome.
Yeah, so we basically, the new MessagePop has basically been completely redesigned, and there's no longer multiple consumers within a single endpoint.
Yeah.
Each endpoint has runs a single consumer, and it's also based off the eventing consumer that they have in their client. And so there isn't this polling loop where we're polling a local queue. So I believe that exception goes away at this point.
Yeah, probably. Yeah. Cool.
Brandon, would it make sense to mention a little bit of history around the RabbitMQ client and its ASIC future, maybe for people interested here in the call? Quickly.
Yes. So, I mean, one of the things that the current RabbitMQ client doesn't have any sort of inherent async support. So one of the things that we've done currently is we've done what we can around it, and I've been able to take advantage of async in a few other ways, but the client itself doesn't. Now, they have said that they're looking at releasing a new .NET client in the future that's going to be, async focused and a few other things like that. So I've been watching, their progress on that. I'm also been looking at a couple alternative clients that are potentially promising, but that's all kind of out in the future at this point. So for now, we've done as much async work as we can given the existing client.
All right. Thanks, Brandon. Comment from Roy on our acceptance testing framework. Are we using that? Are we planning on releasing that? As Andreas has responded, we make a great deal of use around that. We're still not entirely sure whether we want to release that out into the wild. It's out there, it's available, you can use it, but it's not the kind of thing that we're at the point where we're saying, yes, this is the way that end users should be acceptance testing their NServiceBus systems. It's more acceptance testing for our benefit. But it is a trajectory that we're continuing to look at in the long term of how do we better support testing message-driven systems. That's a big deal for us. Not a lot of it happening in V6, but it's definitely on our radar for things that we want to do. Other questions about case studies or experiences in upgrading from version 5 to version 6. So we've been spending a bunch of time one-on-one with various customers, upgrading their endpoints from V5 to V6 and seeing how that's going, and finding ways that we can make that process even easier and smoother by better exception messages, better documentation. Just to give you a sense of what is the state of the documentation, I'm going to share my screen again really quickly and show you our upgrade guide from version 5 to version 6. All right, so over the past year and a half to 2 years or so, we've invested a lot in improving our documentation, and that specifically pertains to upgrade guides, as you'll see over here. So just to give you a sense of how much is actually in here, really going through all of the changes, we've really tried to make sure that everything that you can have an issue with will have been documented. And then also for Azure specific stuff, for example, moving from Azure Service Bus version 6 to Azure Service Bus version 7, the types of changes that are involved in there. So I'd say that the biggest case study, if you will, around upgrading from version 5 to version 6 is we've been doing a lot of hand-holding with customers and finding all the ways in which that doesn't work, fixing that in advance of releasing the beta, updating the documentation. So you should have a fairly smooth experience. And I'd say for all those of you that are on this call that are thinking about doing an upgrade from V5 to V6, send us an email. One of our team will get on a call together with you. We'll do a screen share. We'll walk through it together with you. And really, we want to make sure that anybody that's going through this experience has somebody beside them to make sure that they're never stuck, to the point where we're ready to announce it as a release candidate, and then we expect the whole world to be able to do that by themselves. So yes, right now it's been more anecdotal with specific customers, but there hasn't been what's called a public case study about well-known company X upgrading all of their endpoints from version 5 to version 6. Nor do we recommend that that's what people do. We think that it should be done in a gradual fashion, one endpoint at a time, stabilizing, releasing to production, and seeing how that works. So you really shouldn't be looking at a big end-to-end upgrade. All right.
I mean, that's why we invest so much in the wire compatibility test, right? So you can go one endpoint at a time at the pace you like. Your new endpoints, version 6. And then older endpoints, you upgrade them when the timing is right for you. Again,
Absolutely.
So that's why we have so much wire compatibility testing.
Absolutely. All right, on to the $64,000 question that everybody wants to know. What about .NET Core specifically, because it just got released? The answer is we've been waiting on the sidelines with .NET Core for some time, given the instability and lack of certainty and direction of what Microsoft is going to be doing with it. Now that they've actually done a release and, let's say, put their money where their mouth is, we're now in a position where we can start actually doing real work on moving ourselves in a direction where we can support .NET Core. To be clear, a lot of the work that we've done around version 6 has been a massive preparation for also supporting .NET Core. So we've really refactored and componentized a lot of things and gotten things to the point where .NET Core is on the roadmap. Again, I don't want to say when we're going to have it ready, but there are certain things like removing the MSPQ Transport from the core and making some tweaks to our licensing. And we have a list of certain things that we need to do in order for us to be able to say, okay, now this is .NET Core ready. But I'd say that the big thing for me is that we want to move beyond the, oh, it compiles, release it. Or, oh, the samples run, release it. When we say that .NET Core is supported, that comes with a very strong statement around, if you go into production with this software and there are problems, we will work round the clock. And under strict SLAs, we do have fairly strict SLAs with clients around how quickly we respond and how quickly we resolve problems that pop up. So, Microsoft says that they're ready to support it in production. We still need to see some of that ourselves before us coming along and saying, yes, if you run NServiceBus together with .NET Core in production, that passes all of our most strenuous support cases. Believe me, we'd really love to have it, but it's one of those things that until it is rock solid, we're not going to say that it's released and supported. But it is very high on our list of priorities moving forwards.
Also, I want to add the fact that we do have a lot of good doc on how to do native integration. So, it's not a black and white story where everything has to be .NET Core. If you want to run your website and send me messages onto RabbitMQ and Azure Service Bus, I'll put some links in the chat window. But you can have your website be .NET Core, shooting messages out to your backends, and those backends can be ordinary, old-fashioned .NET 4.5.2, .NET 6, whatever. Backends, right? So you can still start leveraging. You can already start leveraging .NET Core for your front ends if you're that adventurous, I guess.
Right. All right. Next question, Danny Fafaj asks, love to see a matrix of supported features per transport. As I understand that question was answered later on in the chat, that we have some documentation that talks about some of the differences about the transports and what's supported over there. If there's a follow-up to that, please feel free to ask that. Let's see, what else have we got here? So Carlos asking, what specifically on Sagas was addressed that would allow developers to create more robust ones? So on Azure, we've improved the uniqueness story. When it comes to the types of infrastructure changes that we've done around Sagas today, there isn't yet that element that I can say that it's going to turn it into a much more robust actor type model. But one of the things that we are looking at is, for example, finding a way to integrate the Outbox data model with the Saga data model in such a way that you could actually have a fully contained Saga, so that the messages coming in, the messages going out are really, truly one consistency boundary. And that's going to be fairly significant for us in being able to say that we have the most robust actor model that's out there. So today the Sagas are working just fine, they're robust, but we're laying the groundwork for doing even more in that area. And along the way, that will also support more performance improvements. Shimon, did you want to say a few more words about the changes that we've done and the longer-term plans that we have around Sagas, Inbox, Outbox, in the future?
I think it captured the essence of the Outbox being the plans being to build in the Outbox into the Saga, and possibly we were thinking about the concept of an item, explicit concept of an idempotent handler afterwards in the future, which is just making the concepts behind the Outbox more explicit and more robust, as we said. But don't have any specifics to add to that.
All right. So that's that's in the works. Again, we've done a bunch of groundwork for that, and that's going to be coming down the road. Carlos also asked another question. Are there any transports in development using things such as Event Store or Kafka, or is this something that we see value in? Believe me, we love playing with new technology. It's sometimes all that we can do to hold ourselves back from saying, and we want to play with this, and we want to play with that, and we want to rewrite everything in Sharp and all sorts of other craziness. Now, the thing is that at this point in time, we're not really looking at increasing the number of transports that we support, but really deepening the support that we have around the transports that we've got. So for each supported transport, it's important to understand that beyond just there being documentation and upgrade guides and automated tests and a 24/7, meaning around the world support staff that is well versed in the internals of that support, of that transport. There's really a lot that goes into having a fully supported transport. So while while it's easy to say, oh, okay, well, we have a couple of interfaces, we implement those on top of Event Store and Kafka, and voila, we have another transport that you can use. The real question is, if you run that in production and you have problems, can we stand behind that 100%? So what we've done a while back is we've introduced this concept called particular labs, which is a place where we put out various pieces of tech that are more in proof of concept state, that are not fully supported, and that it's really code that if you use it, you should consider it as if you wrote it yourself. That it doesn't have the particular software stamp of approval and 100% 24/7 support and everything that goes along with that. So by introducing particular labs, it makes it easier for us to experiment with various things, put those things out in the community, to collaborate with people that are writing their own transports and to give them feedback, and eventually tend to that garden of open source third-party implementations around the NServiceBus core. But we're very careful. We're very careful about supporting new transports. Daniel?
But let me throw in something we experienced at NSPQ in Dallas. I think we made a number of changes on the transport scheme level, and these changes, they actually simplify if you want to write your own transport. So at NSPQ in Dallas, we made a contest. People from the community and our customers were contributing to that contest. And one person actually wrote on the new transport team at that time, which is a few months ago. It was in December last year. That person actually wrote in less than 8 hours, I think, a transport for Slack. So NServiceBus was sending messages and payloads over Slack channels. So imagine you have a Slack, and in Slack you have a channel called audit, error, and for different consumers, publishers and subscribers, you had channels, and it was fully working and live and using the async APIs. So I think that highlights how simple it's becoming to write your own transports.
Right. We've been doing a lot to simplify it and to take a lot of the, let's call it, magic transaction management and threading and things like that you used to have to know a lot about in order to build a robust and reliable transport, and handle that in a more central way with a lot less surprises. So it's going to be easier to write and support your own transports going forwards. Absolutely. Okay, from Justin and Colin, regarding the MSPQ transport and scaling out, do the hosts now register via some sort of gossip protocol or service discovery mechanism, or do we need to make sure each host is aware of each other? Tim, do you want to say a little bit about how we're doing the MSPQ transport scale out kind of stuff, that, regardless of the host element of it, but the configuration side? Tim, you there?
I guess I can handle that.
All right.
So there is no out-of-the-box magic discovery protocol that would allow you to discover the hosts or endpoint instances that take part in a cluster. There's still at some degree manual operations work. You need to set those instances up on VMs. And then in V6, the model is that there is an instance mapping file that all the upstream endpoints that send messages to this cluster need to have. And that XML file basically lists, okay, for endpoint let's say sales, there are instances deployed to machines, and then there is a list of VMs that have that have an instance of this sales endpoint deployed to. And that file has to be somehow distributed to all the senders, so it can be a shared network.
Okay, that was fairly abrupt.
Latency is never an issue.
All right, it looks like Shimon's gone, not coming back. Andreas, do you want to continue where he left off?
Yeah, I guess. So essentially what we're saying, I mean, we created the lower layers to allow you to plug in whatever routing you want, right? If you are running console.io, Puppet this, Terraform this and that, whatever infrastructure stuff you have, at the moment you can integrate with sort of the file that Shimon, I think, was talking about. I also pasted an example in the chat window how you can essentially build a routing system on top of a SQL database, right? So you can have a centralized SQL database that you would store all your routing information in, and that would be used to, when you're dynamic scaling in and out and whatever you want to do, right? So, so no, we don't have any sort of built-in discovery and so on, but we've gone to great length to enable you to plug it into whatever infrastructure stuff you have, VMware, vMotion, there's plenty of them out there. So, so we're taking that first step, allowing you to easily integrate. And I guess going forward, like you just said, for us to fully claim that we're supporting something, that means so much more for us, right? That means more than just coding it. That means that we need to have expertise on console.io or whatever thing that we sort of officially support, right? So we've taken that first step. David, you're on the call. Would you agree?
Yep, absolutely.
Yeah.
All right, so maybe I'll just wrap it up saying that with the new containerized world that we're all moving into, there's been a great deal of increased interest and innovation around service discovery type mechanisms. Those haven't entirely stabilized 100%, and we want to make sure that what we guide users to do in terms of how they set up their architecture is that there's the part of the logical routing, which deals with message types and logical endpoints. And that is something that is wholly out of the space of the physical realm and service discovery and gossip protocols and things like that. And that is kept in one part of your code and one part of your configuration, and that should be relatively stable regardless of how you decide to do the physical routing. And then the separate physical layer is something that, again, we provide a good out-of-the-box solution that integrates well, as Andreas said, with console.io and a lot of, let's call it the simple, stupid, but it really works and most people can't screw it up type of technologies with an extensibility model where you can go a little bit more crazy. I see that there were a bunch of other questions that were raised and already answered on the chat. So with regards to support for RavenDB going async, and yes, having done that. Jeff Waddell mentioning the upgrade experience from V5 to V6 with Indu and saying that that went well. So great, thanks for letting us know, Jeff. We love hearing that. Changes around the transaction model. I think that there was a response to that, Jeff. I wasn't sure if your yes exactly answer was with regards to the documentation on the transaction. I'm going to assume that it was. If it wasn't, please ask a follow-on question in the chat. Scrolling down a little bit more. Let's see what other questions we have along the way. Questions about the send-only endpoint, custom routing, console.io. Are there plans to implement an entity framework persistence? Specifically interesting would be to use entity framework migrations. Are there plans? We've been looking at Entity Framework for some time now. We do know that a lot of users are preferring to use Entity Framework these days to unhibernate. And for the most part, the fact that we've done things with unhibernate hasn't really gotten into the way of people using Entity Framework for their own code, because we have a very good way of making sure that the same transactions flow across both of them. The only thing that is kind of a, let's call it an annoyance plus, is the fact that you end up having to take a reference on and hibernate, and people tend to kind of crinkle their nose and say, why do we need to have and hibernate assemblies in our production environment just because of NServiceBus? Can't we just have everything on top of Entity Framework? So of the things that I've mentioned that are part of our short-term and longer-term plans, that's one of the things that unfortunately hasn't gotten a great deal of priority. It's always kind of been a, yeah, it would be better if it wasn't like that, but there are so many bigger fish to fry that it always gets delayed. Eventually what's going to happen is that somebody is going to get sick and tired of it and say, screw it, I'm just going to do it. And that's the way that a lot of innovation ended up happening. In particular, is just, somebody says, I've had enough, and then it makes its way in. So I wouldn't be surprised if that happens down the road. And we do have the knowledge in-house to be able to support Entity Framework, so it's not really a big deal on the support elements. Daniel, did you?
Yeah, I think Andreas just posted the link. One of the things we see is that, especially for Sagas and in high performance scenarios, high throughput scenarios, having an abstraction layer on top of raw SQL is usually a performance drawback. So what we are experimenting currently, or Simon is experimenting, he's writing a native persistence for SQL Server. So basically, based on the Saga data, he creates tables and inserts these tables by using the SQL Server JSON support into the SQL Server directly. So there is no overhead of an OR mapper between the Saga persistence and NServiceBus. So that's something to add here as well.
Yeah, and in that mode, we by definition support Entity Framework already, right? Because they will collaborate on the raw SQL transactions. So we are looking at alternate ways of giving you the same thing. So instead of you having to select and hibernate or Entity Framework, you would use the raw SQL persister, and it will play ball with and hibernate and Entity Framework, should you want to use them as well.
Francesco, to your point about Entity Framework would allow to use migrations, that's correct. One approach we're currently spiking, for example, for the native SQL persistence is what we think is even a more robust way, so that the build scripts as an output artifact actually generate the create table scripts and the schema stuff. So then you can actually go with that generated output, check it into source scroll, compare it with test infrastructure, for example, approval tests, and then hand it over to your DBAs to verify if that's actually how you want the tables to look like. So I think it's a different approach to Entity Framework migrations, but we think it's especially in high performance scenarios, it's a slightly better approach.
Right. All right. So we've got already an ever-growing list of questions. Please do keep them coming. A question from Justin Kong again. Anyone in particular tried the tech preview for Windows containers with NServiceBus? I don't know the answer to that question. We've been looking at various bits of container technology. I have a hard time understanding why specifically Windows containers would be a significant difference to any other container technology, because it seems several layers down from NServiceBus. So I might be totally off base here, but I'll let my team tell me how I'm wrong and answer that question better, if that's the case. Crickets.
We'll take that offline, Udi. No, no worries. I mean, I personally haven't looked into it, so I pass answering.
All right, moving on. Hank is asking, what are your plans for supporting other persistence projects like Mongo? Is there any thoughts on allowing better deduplication for persistence in scaled out scenarios? We've had frequent cases where not using the DTC will cause timeout and deferred message duplication. So I'm assuming that those two questions go together. MongoDB is definitely on our list of interesting persistences that that we're looking at for potential inclusion down the road. One of the issues that's been with Mongo for some time is the element of multi-document transactions, which was something that was really necessary for us in the past. With the work that we've been doing around V6 and the conversation that we had before with Shimon about mentioning incorporating the outbox together with Sagas makes us need to rely much less on those type of spanning transactions, which would make supporting Mongo at the same level of robustness and reliability of all of the other things that we're doing, actually something that's feasible and to fit, let's call it, the Mongo philosophy. Now, I believe that since then, Mongo has actually gone and introduced multi-document transactions. I don't remember off the top of my head when. In that way, it's kind of become less of an issue. But when it comes to deduplication, that's something that we've always looked at, trying to support as well as possible in our infrastructure so that you don't need to handle it in such a way of not using the DTC. That's where the outbox comes in. Is that element of deduplication using inbox/outbox. Now, how far along are we at that point? Again, MongoDB is one of those things that we're looking at. The groundwork that we've been laying makes it more likely that we'd be able to support something like that. How soon is that going to happen? I can't really say. What I do understand is that if you're already using MongoDB and you already have your own persistence, really start looking at doing a migration to V6. See some of the changes that are going on in there. It's likely going to make the amount of duplications that you need to that will ultimately bubble up into your code be fewer and farther between. And it will greatly simplify things for you so that as we said before, the outbox gets integrated with Sagas and the rest of our infrastructure, when that's ready, you might not even need to make any changes to your persistence implementation. You can just do the upgrade on the top of that, and that will sort itself out. But like I said, we're not currently doing any MongoDB development internally, and for us to get to the level where we give it a full 100% particular stamp of approval, there's a longer way to go over there. Anybody else want to chime in on the MongoDB side of things on our end?
No, I just wanted to do it. There is a persistor that passes the test. We have a sample. I pasted the link, and we know it's been used on a very big company.
Right. Hank, are you working together with Carlos at the same company where MongoDB is being used? Yeah. Okay. So that's so Andreas, that's the customer that you were talking about. Oh, sorry. I think that a different one. All right, I want to make sure that I'm not skipping things. Question from Stefan. Any further integration with console plan to automate discovery? You know, it's one of those things that we're continuing to look at, but we want to not get the cart ahead of the horse and the cart ahead of the horse, and not tie ourselves too closely to one service discovery mechanism or another until we see how that ecosystem develops. All right. Looking for other questions. Stefan saying MSPQ could run inside containers on Windows. Yes, indeed. MongoDB links. John mentioning that he's not seeing multi-document transactions in MongoDB. They talk about transaction-like semantics. So again, that's one of the reasons why we've been hesitating and putting MongoDB on the back burner for some time. Justin asking, could the Mongo persister be used with Azure Document DB since it now supports the Mongo protocol? Eve, maybe I'll turn that over to you because we have been looking at Document DB as well.
Yeah, for this specific, I don't have the answer. We haven't tried yet. The answer is probably in theory it will work, but we haven't tried yet. But we've had a few questions so far already to support Azure Document DB natively from a few customers, so it's also something that we're looking at. If you have a strong, compelling case for that, we can also talk this through a little bit afterwards, if you like.
All right. It looks like we've gotten to the end of the list of questions in the chat. And we've done that almost exactly right on time. So I do want to thank you all for coming on this call and asking so many great questions. And hopefully we've been able to answer them well and give you an idea of what we've done so far and why we think now is a good time for you guys to really start, if not kicking the tires with version 6, to really start upgrading your endpoints one at a time to version 6. If you have any issues along the way, reach out to us. We're everywhere, and in all time zones. Somebody will be happy to get on a call and help you with it. And we really do appreciate all of the feedback that you've given us, and look forward to hearing more from you and to being on more calls. And if you think something is important, send us a pull request. Engage with us, not just on these calls, on GitHub, on the discussion group. We really do appreciate all of your feedback. So thanks very much for joining this call, and have a great rest of your day and rest of your week as well. Thank you. Bye-bye.